So I will explain user story 7, which revolves around irrigation and water management, and also show the Greek case study, which is in a part related with this user story. The thematic, the domain of this user story is to answer questions, policy questions, for example, as a CAP policy maker or evaluator. I would like to estimate or calculate irrigation water needs in a specific region for a specific growing season. So this UML sequence diagram you will see and this user story can answer potentially those type of questions and to address water scarcity and drought challenges. It for sure integrates FMIS irrigation data and other climate records, IoT data from weather stations, and for example, the Copernicus Drought Observatory. We will see also which CAP indicators are relevant to this user story, and all the actors, which are farmers, FMIS providers, relevant authorities, and policymakers. A reason why this user story is relevant, because the share of EU land affected by water scarcity is increasing and will be increasing according to European Environmental Agency. Various countries, mostly Mediterranean, have a very high water exploitation index, and this is an even concerning issue. To focus on the user story now, like we have farmers as actors, again, as both as consumers, but also as data providers, since the data are owned to the farmer. For example, via their soil irrigation sensor or farm calendars. Also, there are the commercial providers of the solutions that supply the technology, and they process and analyze the data, and also relevant authorities that could have historical data, meteorological maps, or issue drought alerts that could be integrated in such a system. Also, we have policymakers or end users that require specific questions to be answered depending on their needs. So either to evaluate or to take a decision regarding water management at a regional level, but also at a higher level. An overview of the heterogeneity of the data involved in this user story we can see in these images. The challenge is to integrate, for example, CSV data logs and time series with raster format maps, along with polygons that come from IAC systems with the respective metadata, and also some regional water needs depending on the crop type. So we can have a view of how difficult also is the integration of those diverse data sources into a unified system that can produce reliably and accurately indicators and monitor them consistently. So which are those indicators? Those are these user story indicators are highly relevant to result indicators 22 and 23, which are the sustainable water use, and specifically with the share of irrigated land under commitments and the share of utilized agricultural area under supported commitments to improve water balance. Also, it's relevant to the good agricultural environmental conditions, number 4, and impact indicator 17, which is aims to reducing pressure on water resources. Furthermore, there could be indirect links of this user story to specific eco schemes that have to do with soil degradation and erosion. So data on water management practices are highly correlated with those soil degradation and erosion indicators. And also even national and regional authorities that have to complement with the EU Water Framework Directive or to manage national river basins are highly are parties that could make use of this user story. A bit to go in depth now, the off-farm data we are discussing are mostly earth observation data that are used as data sources and products as inputs. For example, evapotranspiration estimates from models, or specific water authorities, European Environmental Agency or other national agencies and databases are available in order to be integrated with on-farm data and CAP-related databases to produce with a specific processing time series or susceptibility indexes, and of course impact indicators, or as we discussed, for example, impact indicator 17, in order to have a better local or national water management plan and better targeted strategic plan redesign. So the UML sequence diagram is includes the farmer, the farm management information system, weather or other repositories and data sources, the CAP administrative database and CAP evaluators. What I would like to pinpoint in this slide is that after the return compliance metrics and sustainability insights arrow, we can see that an arrow goes back to the FMIS system that says issue updated water use guidelines, and then in the last part of the last row of this UML diagram, we can see that this arrow goes back to the farmer. Although the farmer here in this user story is both a data provider and a consumer, we have this arrow in order to showcase what also was asked in the previous question, in the last question, that the farmer should have recommendations, should have somehow visualized an apt benefit on why he or she should give consent to and access to irrigation events and practices in the first place. So this is a way to, let's say, promote and support this this benefit, to highlight this actual benefit for the farmer. Now, a few words about the Greek case study. The main aim of the Greek case study is to test and demonstrate a specific tool that, related to monitoring and data collection it integrates various monitoring and data collection methods, and to essentially crash test it based on in an evidence-based environment. This is why the initial aim was to integrate it with other national EU or national or EU databases and explore the capabilities and the uptake and the benefits this could have for all stakeholders. So the two participating organizations were the Greek paying agency and the Hellenic Agricultural Insurance Organization. So initial interest was expressed by OPCAP, but the collaboration could not be maintained due to internal issues of the organization. So consequently, the team redirected towards the ELGA, which is the responsible insurance body of all agricultural holdings in Greece. And it's closely related, its activities closely relate to the Greek paying agency. The tool we demonstrated, the actual tool we demonstrated was the policy monitoring tool that gathers actual in situ data from pilot test cases of another European funded project. And we took those test case data that come from real farmers and real farms in multiple regions across Europe, but we focus on the Greek farms. And we extrapolate irrigation or fertilizers or harvests variables into the regional area based on the crop classification data product. So this extrapolation have some assumptions that vary a lot from test area from a region to another region. So that's why a crash test was to initially integrate in this methodology an Ajax data from Ajax. As you can see, with the purple on the right side, you can see the crop classification product, and you can see some trends that compare agricultural farms that do utilize digital agricultural solutions and farms that do not utilize agricultural solutions, and exactly what are those benefits in terms of water usage, in terms of yield, in terms of costs. The results, of course, are not black and white, but we can say that every digital agricultural solution has some benefits, and we can see the sectors or the, for example, costs that increase by the use or by using the technology, and also the benefits, but also the downsides and the negative impacts that this solution has. But we can see this in a regional level. So we focused more on the irrigation needs and regarding, and also specifically productivity, which were the main tasks of the participatory organization ELGA. one of the positive case study findings was that we actually showcased how those metrics can complement existing CAP indicators, and we saw that the flexibility of integrating heterogeneous data sources, and also preliminary results also showcased that interoperability with national databases and automation could be achieved, but essential testing was not achieved on the other side, because we didn't have full access to IACS data, or let's say complementary data sources that would improve our results. So accuracy was a downside. One other main finding was that the tool was often viewed from the participants as a feature provider rather than a systemic solution that could be integrated into a broader system, so view it as a holistic solution. And also one other downside is that we had there was no essential official feedback that we could utilize in order to build the future institutional, let's say, trust, or validate in a greater level our case study outputs. I think this is all from my side.